Have you ever noticed that when you walk into a massive casino, the sound of the music, the slot machines, and the overhead announcements, well, they all sound exactly the same, whether you're standing by the entrance doors or, deep in the gaming floor. You just sort of absorb the vibe, and you never actually look up to see where the sound is coming from.
Yeah, that's entirely intentional. I mean, the goal of acoustic engineering in those massive commercial spaces is to completely manipulate your environment without you ever really noticing the hardware making it happen.
Right. Welcome to today's deep dive. We are pulling back the curtain on that invisible infrastructure using a product catalog source from HDTVSupply.
Exactly. And today we're looking at a specific pendant-mount speaker from QSC, the AD-P4T-BK.
Yeah, our mission is to decode the surprising, frankly, over-engineered tech that powers the audio in everyday spaces like, restaurants, retail stores, and transit hubs.
Because when you dig into the specifications for this QSC unit, you quickly realize it's engineered less like a consumer electronic and much
Yeah.
more like, well, heavy-duty industrial infrastructure.
Oh, for sure. Let's jump right into the actual hardware, because this clearly isn't the standard Bluetooth speaker you have sitting on your kitchen counter. It has a 4.5-inch weather-treated paper cone woofer, a 0.75-inch aluminum dome tweeter, and a 30-watt RMS power handling.
Right, but the stat that really stands out is the 150-degree conical coverage. It uses something called a DMT, or Directivity Match Transition, waveguide.
Wait, directivity match transition?
Yeah, it's a mouthful. But if you just bolt a standard speaker to a 20-foot ceiling, physics becomes a real problem. High frequencies, like a snare drum or an announcer's sharp consonants, they tend to beam straight down like a flashlight.
Oh, so it just blasts whoever is directly underneath it.
Exactly. Meanwhile, lower frequencies, like bass, spread out everywhere, so you end up with these jarring dead zones and hotspots all over the room.
So this DMT waveguide, does it physically shape the sound waves as they leave the box?
Yeah, it basically acts like an acoustic funnel. It physically aligns how those high and low frequencies expand into the room so they disperse at the exact same rate.
I picture it like a highly efficient lawn sprinkler.
Lawn sprinkler.
Yeah, think about it. If you have a sprinkler that shoots a narrow stream of water, you have to buy 20 of them to keep a large lawn green. But if this speaker disperses sound uniformly across a massive 150-degree radius, a business actually needs to buy and install far fewer speakers to eliminate those acoustic dead zones.
The sprinkler analogy is perfect, actually. But think about the pressure driving that water. Wide coverage means absolutely nothing if the sound gets completely drowned out by ambient noise.
Right, like a busy casino floor.
Right. And this QSC unit has a frequency range of 65 hertz to 20 kilohertz, and it hits a peak maximum SPL that's sound pressure level of 108 decibels.
Wait, 108 decibels? Isn't that roughly the volume of a live rock concert or like a helicopter overhead? That seems intensely loud for a restaurant ceiling.
Well, you aren't usually blasting it at full volume. It's really about headroom. If a transit terminal is quiet, the system pushes subtle background jazz without losing the low-end warmth.
Makes sense.
But if a train pulls in and the ambient noise floor just spikes, the system has the raw power to push a crystal-clear emergency announcement through that roar without distorting. It's about maintaining tonal consistency, regardless of the environment.
That actually brings up a huge logistical problem, though. If these speakers have this massive 150-degree spread, you're going to install them near entryways over humid patios or right next to blast chiller HVAC vents to get maximum coverage?
Right.
So how does a paper cone woofer not just instantly disintegrate in that kind of drafty, humid environment?
Because commercial environments are fundamentally hostile to electronics. It's not a climate-controlled living room. That's exactly why a $330 speaker is built with an IP34 dust and water resistance rating.
Wow, IP34.
Yeah, and it has a UV-treated ABS enclosure so the plastic doesn't degrade under industrial lighting, plus a magnetic steel grille.
I'm still stuck on the IP34 water resistance, honestly. This thing is hanging from an indoor ceiling. Why armor-plated against moisture?
Well, think about the vulnerability of the wiring. Commercial systems often daisy-chain dozens of speakers together on a single line.
Oh, so they're all connected.
Exactly. This model uses a 4-pole Euroblock connector, which basically allows audio to pass through from one speaker to the next. If moisture from, say, a humid restaurant kitchen condenses on those exposed terminals, it shorts out the entire chain.
Ah, so one bad connection takes down the whole casino floor.
That is the nightmare scenario. To prevent it, the engineers designed a sealable input cover that specifically tucks over that 4-pole connector, locking out ambient moisture.
Oh, that's smart.
Oh, yeah. They aren't just building a speaker, they're basically building a survival tool.
So looking at the QSC AD-P4T-BK, it's clear this isn't merely a music player. It's a highly engineered spatial efficiency tool built to blast sound evenly and survive whatever commercial ecosystem you throw it into.
It really is the rugged, invisible backbone of the modern public space.
Totally. So the next time you are walking through a massive retail space or a casino and you notice the music sounds perfectly even no matter where you stand, take a second to look up at the ceiling. What other invisible engineering choices are quietly manipulating your experience of that environment?